This is Euclid Book 7, and we're going to start with some definitions here, but I wanted to stop the journey right here, right now, for just a second. And I wanted you guys to understand something. Euclid is a great way to get you beyond early arithmetic and early algebra. But it is a great starting point. It is certainly not an ending point. By the time I'm finished covering everything with you people, we're going to be covering much higher mathematicians than Euclid himself. Euclid is a starting point, not a finishing point. Okay? I used Euclid to get you out of early arithmetic and early algebra and early geometry. That's what I used Euclid for. I said, okay, we're going to expand your mind a little bit. But as I cover Book 7 of Euclid, we're going to be talking about prime numbers. We're going to be talking about things that are way beyond Euclid. We're going to start with Euclid. Starting with Euclid, fine, but we're not going to finish with him. Oh, no, no, no. There are higher mathematicians that talked about much higher concepts in prime numbers than what Euclid said. So we're starting with Euclid, but we're certainly not going to end with him. And I'm getting help on this from Booball 1067. Okay? So what we're doing, this is going to be the starting point, but it's not going to be the ending point. I'm going to cover much more as I cover Euclid Book 7 than just Euclid Book 7. Guarantee that. And the first thing I'm going to do is I'm going to read a definition from Euclid, and I'm going to get your minds away from a concept that you were taught back in algebra and early arithmetic. Okay? And unit is that by virtue of which each of the things that exists is called one. That's the very first definition of Euclid Book 7. Now, here's the problem. Most of you people have been taking all this arithmetic and early algebra, and you think that a unit is exactly one. Well, that's a unit right there. That's one pin. Well, you can use the one pin to measure a line. You can do that. Okay, this is one pin. You can have one statue. You can have one brick. So that's a unit. But Euclid was thinking a little bit differently, and there are a lot of mathematicians that think even way differently than that. In this case, the unit that we're referring to can be like, let's say you have a weight scale, all right? And you have 4 buckets, and in each one of the buckets is 20 bricks. Okay? Each one of those buckets is a unit. Even though they have 20 bricks inside of them, they're units. They're unit sets. Okay? All right? There's a set of 20 in each unit, but it's a unit. So you can have a collection as a unit. Just like when you collect action figures. If you put 15 of those action figures into a single bucket, now you have a unit. Though technically the bucket is one, what's inside of it is a collection. And you'll find this out as we do numerical concepts later on. You can have numerical units that, though they're treated as one unit, they have a collection of stuff inside. Okay. So, let's say you have that scale, you have these 4 buckets, each one of the buckets has 20 bricks inside. So you hang those 4 buckets on one end of the scale, you have 80 bricks, but you actually have 4 units. 80 bricks, but 4 units. You understand what I'm talking about now? Okay. A number is a multitude composed of units. Okay. The 4 buckets is a number, and it's composed of each bucket. We're not going to count the 80 bricks inside the bucket. And we're not going to count the 80 bricks inside the 4 buckets. We're just counting the buckets. Okay? The number is the 4 units. But each bucket is a unit. Okay? And this is where number sets comes in. All right? A number is a part of a number, the less of the greater when it measures the greater. Okay? So, a number is a part of a number, like the number 2 is a part of 4 because it can measure 4. 2 2's makes 4. 2 is a unit, 2 is a unit, 2 and 2 together makes 4. Okay? Now, we could say it this way. We have 2 buckets. Each bucket contains 2 bricks. Alright? So 2 units of 2 makes 4. Okay? Now, inasmuch as a number is a part of a number, the less of the greater when it measures the greater, a number is parts when it does not measure another number. Okay? 3 doesn't measure 4, so it's a part. The greater number is the multiple of the less when it is measured by the less. Okay? The greater number, which should be 4, is a multiple of the less, which is 2, when it is measured by the 2. 4 is a multiple of 2. It is twice a multiple of the 2. Okay? So basically 2 times 2 is 4. An even number is that which is divisible into 2 equal parts. Okay? The 2 equal parts would be 2. 4 is divisible by 2, so 4 is an even number. An odd number is that which is not divisible into 2 equal parts, or that which differs by a unit from an even number. Okay? So, in the case of 3, nothing divides 3. In the case of 5, you have 2 2's and a 1. Well, the 2 2's are even numbers, but the 1 is not. That's what he was saying. So, 3 and 5 are both odd numbers, but for 2 separate reasons. 3 cannot be divided into anything, except by 1, maybe. But even if we were to go that far, 1 couldn't be divided into anything at all. Get the picture? But the thing is, 5 can be divided into 2 units of 2 plus a unit of 1. But it'll never be even. An even times even number is that which is measured by an even number according to an even number. Okay? Well, 2 times 2 is 4. Okay? Because you can measure 4 by 2. An even times odd number is that which is measured by an even number according to an odd number. Okay. An odd times odd number is that which is measured by an odd number according to an odd number. Now here comes something critical. A prime number is that which is measured by a unit alone. Now, that is a very basic fundamental concept of a prime number. We're going to well expand on that in the future lessons. Like I said, we're not going to just focus on what Euclid says. We're going to go way beyond that. You're going to see that in my next video. Numbers prime to one another are those which are measured by a unit alone as a common measure. A composite number is that which is measured by some number. Numbers composite to one another are those which are measured by some number as a common measure. Now we're going to way expand on this in my next video. This is just gloss over here. Alright? A number is said to multiply a number when that which is multiplied is added to itself as many times as there are units in the other, and thus some number is produced. And when two numbers having multiplied one another make some number, the number so produced is called plane, and its sides are the numbers which have multiplied one another. And when three numbers having multiplied one another make some number, the number so produced is solid, and its sides are the numbers which have multiplied one another. Now this is starting to go into the concept of physical planes, which are two-dimensional figures. Your square, your rectangle, your circle, I could go on. And your solids would be three-dimensional figures like your sphere, and your cone, and your cylinder. That's what he's trying to get at. Alright? Now, like I said, that's that elementary way of doing things, but it starts you off and gets you out of that elementary arithmetic and algebra. And that's what Booball 1067 and I want to do. We want to get you out of that and get you into the calculus. Okay? We want to expand your mind. We want to expand you into the universe. Now, all this stuff you've learned so far is cheap garbage compared to what we're going to teach you. Okay. So, like I said, Euclid is the first stepping stone, but it is certainly not the last. And when you find out the things we're going to teach you about prime numbers, you have no idea. A square number is equal multiplied by equal, or a number which is contained by two equal numbers. And a cube is equal multiplied by equal and again by equal, or a number which is contained by three equal numbers. Now, what have I told you in previous lessons of Euclid? A square is not just some big number 2 that is a superscript to an x. It is a square area. Change your mind about that. Quit thinking that it's some kind of a superscript. It's something more important than that. A cube is the same way. It is a literal three-dimensional cube. We're talking about like those blocks. You remember how you used to play with those blocks when you were a kid, those alphabet blocks? Same concept. We want you well past the number 3, which is a superscript to an x. When you see that number 3, which is a superscript to an x, we want you to think of a physical cube. And get out of that babyhood elementary algebra and arithmetic. You're way past that now. Numbers are proportional when the first is the same multiple, or the same part, or the same parts of the second that the third is of the fourth. How many ratios and proportions have we talked about in the last 2 books of Euclid? I think you're well past fractions and division. Similar plane and solid numbers are those which have their sides proportional. A perfect number is that which is equal to its own parts. Those are the 22 definitions of Euclid Book 7. Those are very cheap definitions. We're going to go way beyond that as we cover Euclid Book 7. But I wanted to destroy your concept of what a unit was, what a square was, what a cube was, what a solid is, so on and so forth. What they teach you in elementary algebra and elementary arithmetic is nothing compared to what we're going to teach you. Got to get some of those concepts out of your head or you're never going to understand calculus. And it's the calculus. Okay? When you talk about calculus, you're talking the calculus. You are way past algebra now, kids. You're even out of elementary geometry. The next 3 books of Euclid, what we're going to teach, is going to take you well past simple algebra, simple geometry, and simple arithmetic. So, there you are. There you have it. We want you not only to know what odd numbers, even numbers, so on and so forth are, we want you to also see them. That's why we're going to use magnitudes. Euclid's magnitudes is a great way to visualize this stuff. If you don't visualize this stuff, never get past the calculus. We don't want you just to see a bunch of numbers. We want you to see what the numbers really actually look like. Square areas, square surfaces, or cube surfaces, sorry, cube surfaces. We want you to see that. Math is not something that you flood a bunch of numbers with. It is something that you see. It is patterns that you see. You're going to see a lot of patterns as we go along with this. So, I want you to draw the numbers as well as know the numbers. And we're going to draw the numbers using magnitudes. And when we show you these prime number patterns, and believe me, we're going to do an in-depth discussion of prime numbers as we go through Book 7. Oh boy. So like I said, Euclid's a great way to start, but we're going to go way past that. Alright? Matter of fact, as Booball 1067 and I discuss prime numbers, we're going to actually draw up the magnitudes and let you see the patterns. If you don't see it, you'll never understand it, and you'll never get past the calculus. It's that simple. You have to see it in order to understand it. Alright, I will tell you more in a future video, so stay tuned.